exponential functions. And by the end of today, you will be able to analyze exponential functions by describing their domain, range, and behavior in asymptotes. And then we're also going to use exponential models to solve practical problems. So I've asked you to look at the colorful graph on page 304. Okay, so let's take a look at that together. Okay, and that's going to give you a bunch of different types of exponential functions. So you have done exponential functions before. I'm hoping looking at this will jog your memory some. Okay, so we have functions on both sides. Okay, we have ones that are going down from left to right. They're approaching the x-axis. Others that are starting at the x-axis but then are going up. Do you guys remember what the two different types of functions are called? Mm-hmm. Yeah, growth and decay. Okay, so if it's decay, it's going to be getting closer and closer to the x-axis. Okay, if it's growth, then it's going to be going away from the x-axis on the right side, and that can either be positive or it could also be negative. Okay, it could be going in the negative direction. Do you guys remember the differences in the equations between the exponential and or exponential growth and decay? Okay, so what type is that? If it's greater, if the base is greater than 1, it would be growth. What do we notice about all of these equations? They're less than 1. They're also what? Greater than 0. Okay, so that is how we determine growth and decay. And that's something that we're going to write down on our notes today to make sure we got that. You guys remember doing exponential functions in Algebra 2? Yeah? Okay, so we have an important box here. That's what we're going to start with. Okay, and it tells us that f of x is equal to a to the x power. I'm just going to box that in. Okay, so that would just be a basic exponential function. F of x equals a to the x. Okay, or sometimes you'll see b to the x. And then it tells you that this would be where your a value is greater than 0. A cannot be 1. Think about if a was 1. What would the graph look like if a was 1? Be a straight line. Why? 1 to any power is 1, right? Okay, so 1 to any power is 1, so that's why our a value can't be 1. Okay, it also has to be greater than 0. Okay, because 0 to any power would be what? Be 0. Right, 0 to the second would be like 0 times 0. Okay, alright, so then it says the domain, it has the domain, and then they have this R looking symbol. What does that mean? All real numbers. Okay, so your domain for all of these is going to be all real numbers. And that fits in with what we've been studying this year. Because remember, the main things we talked about were what? When you don't have a domain of all real numbers. What were the main things we had to watch out for? Fractions and radicals, right? Okay, and there's one other one that we mentioned that we'll actually talk about in this chapter. And then the range is 0 to infinity. And that's for both of these functions. Now, sometimes your range is going to fluctuate. But if we look at this graph, the range, you can see all the points are above 0, and they're going up, so it would be 0 to infinity. And then for this one, the range would be 0 to infinity. Again, they're 0 or they are above. And then it tells us that the line y equals 0, which we know is the x-axis, is the horizontal asymptote. Okay, so we're going to go ahead and put that in. this represents growth or decay? This is going to be growth. Okay, and then growth is going to be on the right side. You're going away from the x-axis. Okay, so you could either be growing in the positive direction, or you could be growing in the negative direction, but that would still be growth. Okay, so for growth, your base has to be greater than 1. Okay, and again, it's going to be going away from the x-axis on the right. Now decay, which is modeled in the second picture, you can see is going to be approaching the x-axis on the right. Okay, so this approaches the x-axis on the right. Okay, so it's getting closer and closer to the x-axis for this example specifically. Do you guys know what else it could approach? If not the x-axis. What else do we know that graphs approach? Yeah, the asymptote. Okay. All right, so if it's decay, then the base value is going to be between 0 and 1. Okay. And we can just put, this is going to go away from the x-axis on the right. And then this says, after completing example 1, answer the following. So we're going to keep this in mind. How do you find the horizontal asymptotes? And then if there was a reflection of the parent graph, how would the range be affected? Okay, so we're going to do example 1 first, and then we are going to come back to that. So for example 1, we have to graph the function, and then we're going to state the domain, range, and asymptote. And we are going to use interval notation when we state the domain and the range. Alright, so for A, we have f of x equals 10 to the negative x. For B, we have y equals 5 to the negative x plus 1. And C is h of x equals 2 to the x minus 4 plus 1. What are you guys thinking you'd do first to graph these? Okay, yeah, you could use your graphing calculator, right? You could use the table on your graphing calculator. What if you didn't have a graphing calculator? What would you do? Excellent investment. What if you didn't have the money?
Get along.
How can you graph a function without a calculator? Okay, yeah, so you can pick values, right? Okay, so we can make a XY table. Okay, so I can just do negative 2 to 2, plug it in, see what I get. So if I have 10 to the negative x, if I'm plugging in negative 2, this is like 10 to the negative 2, which is like 10 to the second, which is what? 100. Which means for negative 1, this is really like 10 to the first, which is going to be 10. What's anything to the 0 power? 1. Okay, and then 10 to the negative first power, what's that going to be? Yeah, good, 1 over 10. Remember, if it's negative, it goes on the bottom. Okay, and then 10 to the negative 2 is 1 over 100. Good. Okay, so then I'm going to go ahead and graph this. So I want to at least get my negative 1 10 point on there. So I'm going to go depending on what calculator you have, if you have one of the flat calculators, they're really good about showing you that it continues forever with the different colors. If you have an older one like I do, it looks like the graph stops, but the graph is not just going to stop. You are going to have a continuous function that will keep going. Now, if I look at my graph, I can see that my line is approaching the axis. So my line is approaching y equals 0, which means that is going to be my horizontal asymptote. So like we said earlier, your domain is going to be all real numbers. For your range, you have to look and see where the points go. So see how it's getting closer and closer to 0? And then all the points are above 0? So then our range would be 0 to infinity. Okay, and then because they're getting closer and closer to the line y equals 0, that's going to be my horizontal asymptote. Alright, and then let's try B. So we'll do the same thing where we're going to think of our table. Okay, so if I do 5 to the negative negative 2, it's just like 5 to the second, which is what? 25, and then I'm adding 1. So we get 26. Okay, 5 to the negative negative 1 is just going to be what? 5. 5 plus 1 is 6. Anything to the 0 power is 1, but then I have to add my other 1, so I will have 2. 5 to the negative first is what? 1 over 5, so plus 1 would be 1 and 1/5. And then for 2, it'd be 1 over 25, so this would just be 1 and 1/25. Okay, so I'm going to keep this by 1, so I'm just going to put that first point a little bit off of it. So if this is 5 and 5, at negative 1 I'm at 6. At 0 I'm at 2. At 1 I'm at 1 and 1/5. And then as I go on, these are going to get smaller and smaller. So because these are getting exponentially smaller, that's why some of your calculators are not going to show that it goes on, and it's just the technology. The pixels cannot go that small, which is why for some of you it'll look like it stops. And that's also why we have to know, oh, it looks like it stops, but it is going to keep going. Okay, so now if I'm looking at this, see how my line is approaching not the axis, but instead it's approaching what value? 1. So then your horizontal asymptote is going to be y equals 1. Okay, so your domain is the same, negative infinity to infinity. Your range are all the points that are above what? 1. So this is going to be 1 to infinity. And then your horizontal asymptote is going to be y equals 1. Alright, and then we'll do the last one. Okay, so I'm going to start off negative 1, negative 2, negative 1, 0, 1, 2. Okay, so if I plug in negative 2, that's negative 2 minus 4, which is negative 6. So 2 to the negative 6. Do we know what 2 to the third is? 8. So then if we had 2 to the 6, it would be like 8 times 8, which is 64. So this would be 1 over 64 plus 1. So 1 and 1/64. If we had negative 1, that's like negative 5. 2 to the 5th is what? 32, yeah. So this would be 1 over 32 plus 1. So 1 and 1 over 32. I plug in 0, remember this is 0 minus 4, not just to the 0 power. What's 2 to the 4th? 16, so this would be 1/16 plus 1. If I plug in 1, I'll get negative 3, so this would be 1 and 1/8. If I plug in 2, I get negative 2, so this is 1 and 1/4. Okay, now I'm going to keep going because I feel like I can get some better points. So if I plug in 3, I get negative 1, which is a half, so this is 1 and 1/2, or 1.5. If I plug in 4, that's when I get 2 to the 0, which is 1. 1 plus 1 will be 2. 5 minus 4 is 1. 2 to the first is 2. 2 plus 1 is 3. So now I have some good points that I can plot on my graph. Okay, so then at 5, I'm at 1, 2, 3. At 4, I'm at 2. At 3, I'm at 1.5. And then from there, it looks like I'm getting closer and closer to what value? Yeah, I'm getting closer and closer to 1. Okay, so I'm going to put my horizontal asymptote in there. So what's the domain? All the numbers, negative infinity to positive infinity. My range for this one is what? 1 to infinity. Okay, because they're all above 1, all the points. And then the horizontal asymptote would be y equals 1. Okay, so now we're going to go back up to 1 and 2, and we're going to give those a try. Okay, so you and your elbow partner figure those out. Okay, so if we're not writing something in here, we need to be thinking about that. Yeah. So okay, so there's a couple different ways that you can find the horizontal asymptote. So the first way let's talk about is if you just had the graph. If you just had the graph and you didn't have the equation. Nick Switzer, what do you think? How do we find the horizontal asymptote? Just by looking at the graph. Exactly, so it's going to be the line that the graph approaches. Okay, excellent. And then, Henrik, how can we use the equation to help us? Okay, so you can look at the constant term in your equation. So if you notice these, see how I had plus 1 here? And then what was my horizontal asymptote? Y equals 1. Anytime I didn't have anything added or subtracted, what was it? It was 0. Okay, so I said the value types of reflections. Do you guys remember what they are?
Over the line.
Over the y-axis and over the x-axis. Okay, so we're going to do both of them. Because why not? Okay, so when I'm talking about the parent function, I'm talking about these functions here. Alright, so let's say that it was reflected over the x-axis. I'll just take this one and do a reflection, okay? Do a flip. So that's just a rough sketch. Anybody tell me what the range would be? Uh-huh.
Would it be, okay,
Just tell me, yeah, tell me.
it'd be every number except for the asymptote?
Well,
Actually, hold on, how did you reflect it?
so I just flipped it over the x. So yeah, the asymptote wouldn't be included, but where are the rest of the points going? If you flip it over the x-axis. Yeah, JC? You're really close. So, and that's what my last class said too. So he said 0 to negative infinity. So we just have to flip them around, but tell me why. Negative infinity is lower than 0, right? You always want to go from your lowest point to your highest point. So this would be negative infinity up to 0. So this means all the points would be either at 0, which is the horizontal asymptote, or below it. Instead of before, where they were at 0 or they were above it, right? Okay, now if we did a reflection over the y-axis, okay, if we did it over the y-axis, we'll do the same one, right? Instead of it going this way, it would be going this way, which really looks just like this function. And what would our range for that be?
I'm gonna take this one.
Okay.
It would be, 0 to infinity.
Yes, good. Okay, so it's still all the points above 0, right? So if it's a reflection over the x, that's definitely going to change your range. But if it was a reflection over the y, then the range isn't changed. Okay, so something to think about when you are doing your homework tonight. All right, now we're going to move on to some practical problems. Some real world issues we got going on here, like these dang rabbits. Okay, so the rabbit population at a local zoo was initially 200. It's estimated that the population is doubling every year. So what we're going to do is find a function that's going to model the number of rabbits after t years, and then we're going to estimate the population after 7 years. Okay, now I apologize because I really should have put this little thing before I did that example, so we're going to flip to the back and do this. The common model for an exponential function. Your common model for an exponential function is not just y equals a to the x. What you'll usually see is y equals a times b to the x. Does that ring any bells from last year? Okay, because b is going to be the base value, but it's also going to be the ratio. Okay, so the ratio of how fast it's either growing or decaying. And then your a is going to be your initial value. Okay, so your a value is going to be your initial value. So using that model, we are going to find a function for the rabbits after t years. So if I start with y equals a times b to the x, okay, a is going to be my initial value. How many rabbits did I have initially? 200. Now b is going to be the ratio. So how fast is this growing? It's doubling. So my b value would have to be 2. So if it was tripling, my b value would be 3. If the population was getting halved instead of doubling, function. So for your function, you have to have like y equals or f of x equals. Okay, 200 times 2 to the t. And we're using t because it says after t years. Okay, so not x, but t for that. So you also want to try a few values to make sure this makes sense. So if you plug in 0, are you going to get 200? Yeah, because 2 to the 0 is 1. 1 times 200, 200. Okay, after 1 year, there should be 400 rabbits, right? So 2 to the first, 2 times 200 is 400. Yep, and then I would usually check one more. So after 7 years, we would have y equals 200 times 2 to the 7. Do you guys remember what 2 to the 6 was? Remember? It was 64, right? So 2 to the 7 is going to be double 64, which is 128. And then, so if we're doing 128 times 200, let's just do 128 times 2. What's that? 256, and then I'll just put my 2 zeros on. Okay, so there'll be 25,600 rabbits. Yes. That's why we have hunters, right? All right. Okay, so then we are going to jump down now to the compound interest. Do you know who talks like that? Elmer Fudd. I was listening to the radio last weekend. Somebody said something about Elmer Fudd, and the kids were like, "Hey, who's that?" Because you guys don't know Looney Tunes. That was from my childhood. All right, so compound interest. This is also something that you have done before. So the formula is A of t equals P 1 plus R over N to the NT. Okay, great. We have a bunch of letters, right? So we're going to go over what each one of those means. So the first part, the A of t, that's going to be the amount in the account after t years. Okay, so A of t is going to be the amount after t years. And then we have what's called the principal. The principal is also going to be an amount of money, but this is going to be the initial value. So if you were investing, it's how much you put into the account initially. Your interest rate per year is going to be a percentage, and this percentage is going to be written as a decimal. So if you're given a percent and you need to write it as a decimal, do you guys remember what you need to do? 2 places to the decimal, 2 places to the left, okay? Because you're really just dividing by 100. So then N is going to be the number of times interest is compounded per year. Okay, so for that one, they might say, oh, interest is compounded quarterly. How many quarters are in a year? 4. Could say daily. How many days are in a year? Yes, and we are just going to do 365, not the fourth of a day. What about weeks? What if it was weekly? 52. What if it was, yeah, what if it was bi-weekly? Bi-weekly technically means it would be twice a week.
Bi-weekly, isn't that?
What's that? Yeah. And then what about annually? Once. Okay, and then for years, this is going to be the time in years. And then I did leave a little spot there for a note. So do not round until the last step, okay, when you're doing these calculations. Okay, do not round until the last step. Now, if we are dealing with money, we are always going to be rounding to what decimal place? The 100. Okay, so you should never just have the dollar sign and then 1 place after the decimal. It's always going to be 2 places after the decimal. so for example 3, it says if 2,500 is invested at an interest rate of 2.5% per year, compounded daily, find the value of the investment after the given number of years. Okay, and then for A, we're doing 2 years. Alright, so if we're 2 years, that's going to be my T value. My 2,500 is going to be what variable? Yeah, it's going to be the what? Principal. Okay, and then the 2.5% is a year. Cheyenne, how am I going to write that as a decimal? Yep, 0.025. Okay, and then if it's compounded daily, that's going to be my N value. So we just talked about if it was daily, it'd be 365. Okay, and then we're going to find the value, that's your A of T value. So I want you to see if you can set up the equation and then find your solution. Oh, thanks. And then you're all done. Yes.
Yes, ma'am.
Okay, how do we do? Really, if students get this question wrong, it's not because they set it up incorrectly, it's plugging it into your calculator. Okay, so you have to find what way works for you. I know some people like to plug it all in at one time. Others of us like to do it just one step at a time. Okay, for this one I am going to show you my preferred method. So my preferred method, I would start with the 0.025 and divide by 365, and then I would add 1 to it. Then I would raise it to the power of 365 times 2, and then I would multiply that value by 2,500. Okay, and then you should get $2,628. Is this, what's my change going to be? 17 cents. So remember to follow your normal rounding rules. Okay, so a lot of times that's how I like to do it, is piece by piece. And then for B, we're going to do 6 years. So really, everything is going to be the same except for your time T. Okay, because in this case, T would be 6. So I have A of T equals 2,500, 1 plus 0.025 over 365. 365 times 2. Okay, and yes, you can put it all in at one time. So
You did 2 again.
oh, thank you. 6. Thank you. That's the only thing that changed is your 6 years. Okay, so if you put it all in at one time, you're going to have to utilize your parentheses. So 2,500 times, and then it would be 1 plus, and then I would have to do my parentheses over 0.025 divided by 365, close, close, and then to the power of, and then again I would put these in parentheses, 365 times 6. Okay, and then you should get $2,904.57. How did you guys do? Were you able to get the same exact values? Yes. Okay, make sure you guys do that on your calculator if you haven't. Alright, and then example 4 is a little bit different. This says to find the present value of $10,000 if interest is paid at a rate of semi-annually for 4 years. So whenever you're trying to find the present value, what you're actually trying to find is P, okay, is the principal. Okay, so the present value of 10,000, that would be the amount in the account. What's that? I know. Okay, and then it's paid at a rate of 7%, which would be 0.07. And if it's compounded semi-annually, do you guys know how much that is?
Twice a year.
Twice a year. Okay, so semi like semester, twice a year. Okay, and then for 4 years, so your T is going to be 4. Okay, so now let's try to set up this equation with our given values. So my A of T is 10,000. So 10,000 is going to equal P times 1 plus, my rate is 0.07 over semi-annually, so 2 times a year, and then 2 times 4 years. Okay, so if I'm going to solve for P, I'm going to have to evaluate the rest of that equation. So the first thing I'm going to do is 0.07 divided by 2, which, what is 7 divided by 2? 3.5. So this is just going to be 1.035. And 2 times 4 is going to be 8. And then these are stuck together with multiplication. So if I'm going to get P by itself, I'm going to divide by 1.035 to the 8th. And the reason why I'm writing it like that is because I don't want to round. Okay, so do not round this. Okay, so we're not going to round until we get to the very end. Okay, so we're going to do 10,000 divided by 1.035 to the 8th. So 10,000 divided by 1.035. Okay, and then we should have got $7,594. And how much change? 12 cents. Okay, because after 0.11, there's a 5. You always look at the 1 directly after it, and that is going to round it up. All right, questions for me on that? You guys were able to get that on your calculators? All right, then the last thing we're going to talk about today is something called APY. So if you have an investment that earns compound interest, then you will be interested in what's called the annual percentage yield. Okay, which is called the APY. So the APY is a percent. Okay, so what's happening is you earn a certain percentage, but each time you compound the interest, that percentage is applied. So at the end of the year, you don't get just 7% on all your money. It depends on how much it's compounded, but you actually get a little bit more than the advertised rate, unless of course it's annually, because then it would just be one time per year. So to find the APY, you have to find the simple interest rate that yields the same amount at the end of 1 year. So what is simple interest? It is just the formula 1 plus R. Okay, and how does that come to be? Well, the 1 represents the 100% of your earnings. And then the R is going to be your rate. Okay, so the annual percentage yield rate. Okay, so the 1 is going to represent your percentage. And then because it's at the end of 1 year, that means your t value is always going to be 1. So if we're going to find the APY for an investment that earns interest at a rate of 4% per year, compounded quarterly, we're going to have to know our values. So our value for N, if it's quarterly, is going to be what? 4. Okay, if it's 4% per year, my rate is going to be 0.04. And then we already talked about, if you're finding the APY, your t value is always going to be what? 1, because it's going to be at the end of 1 year. Okay, so your A value is going to equal the principal. We don't have the final amount. We don't have the principal amount. That actually is not going to matter. So you have 1 plus your interest rate divided by the number of times per year it's compounded. Okay, and then the number of times of year it's compounded times 1 because it's going to be 1 year. What's 0.04 divided by 4? 0.01. So this is 1.01 to the 4th power. Okay, so we're going to go ahead and calculate that. And remember, we are not going to round until the very end. So if I'm actually going to write out this whole entire decimal here. So you are going to get P times 1.04060401. Okay, your simple interest, your 1 plus R, is this value here. This is your simple interest. Okay, so if your simple interest is equal to 1 plus R, that means 1 plus R is going to equal 1.04060401. Okay, and then your rate would be what? Yeah, 4 point something, right? Okay, because what could I do to both sides? Subtract 1. So if I subtracted 1 from both sides, I would get my rate is 0.04060401. And then what would I want to do to that to convert it to a percentage? I have to do what to convert it? Multiply by 100, right? Because it's the percentage. So if I multiply by 100, I'm going to move the decimal 1, 2 places. And then you can just always round this to the nearest hundredth. So this will be 4.06%. So annual percentage yield. Okay, so at the end of 1 year, if it's compounded quarterly, that means really the interest that you earned, the yield, the percentage that you got yielded, was 4.06. Okay, so like when you're dealing with mortgages and all that stuff, when it's a certain percentage, if it's a certain percentage on a large amount, like a house, okay, that's where those decimals are going to come in handy. Alright, so we're going to take a look at our schedule. So you have a quiz on Wednesday, and we're going to do a little bit of review before the quiz, but really your review is just going to be doing your homework. Okay, and I'm going to show you your homework on Google Classroom right now, and then we're going to talk about how to do homework logs accurately.